Hello and welcome. This is question number 6. Sorry to double check. I almost said 5 then. This is question number 6 for your M Mechanics Unit 1, M1, for Excel. Now, this question is all about momentum. So you could have actually done this if you did GCSE Physics in Year 10. But, never mind. Anyway, this is further math, so forget about that. So what we've got here is we've got a mass of P. Now, obviously, in the context of the question, it says these are railway trucks, but I don't want to insult anyone with my bad drawings. Obviously, I haven't done that already. So anyway, I'm just going to model them as just blocks. It tells you to model them as particles, but I'm just going to be a crazy kid and ignore that. Probably best you don't. But anyway, so we're told the P has a mass of 1,500 kilograms and is initially travelling at 10 metres per second, and then after the impact travelling at 4 metres per second. And then Q has a mass of 2,500 kilograms and is initially travelling at a speed of 5 metres per second. And the first part says, okay, what is the final velocity of Q? So the only way that we could possibly work this one out is by using our idea. Now the first thing I would write down in this question is saying, okay, well, the total momentum before equals the total momentum after. This is after the collision. Now if you wanted to, and you were like, you just had too much time in your hands, then you could write the conservation momentum pointing to this, or whatever you want to, but that's a key thing. I mean, you don't necessarily need that to get the marks, and you kind of show that by doing your working out, but it just means the examiner can't be nasty and say, well, you don't actually put that in words. So how do I know these figures that you're just like pointing towards that mean this? So basically it's just if you get a bad examiner. So to recap this, we need to remember what momentum actually was. So momentum is mass times velocity. So total momentum before is equal to total momentum after. Okay, so what we need to do is you don't really need to consider the initial speeds. You can just go straight on to working out what the final ones would be. So you don't need to, because obviously 1,500 times 10 is going to be the same as 2,500 times 5. You don't need to work that one out. That's obvious, because we don't have to do anything else with that. Okay, so what you would do is you do, okay, mass times velocity, mass times the final velocity. I was going to say actually, so can you do it this way? Sorry, I'm just going to double check something. Yeah, sorry. You do need to include the initial speeds. I don't know what I was on about. It's a bit early for this. So I'm doing it as the first thing part of in my morning. Anyway, so the total momentum before is equal to total momentum afterwards. So the initial velocities occur before the collision. So work out the total of that. So therefore, 1,500 kilograms times 10 meters per second, because that's the initial speed it's going at, plus 2,500 kilograms times 5 meters per second. And that is equal. Now, that's total momentum before, because it's the momentum of P and the momentum of Q. So then the total momentum after must have stayed the same, because we can't lose any momentum, it's not allowed. So therefore that is equal to 1,500 kilograms, and that P has reduced its speed to 4 meters per second, so you times that by 4 meters per second, and that you add that to 2,500 kilograms, but we are not told what the speed of that is, so I just put V meters per second. So you could put anything, you could put speed. Oh, I probably wouldn't put that, it wouldn't look too good. So anyway, work this out. So we input that into your calculator. You should get 27,400 500 kilograms meters per second. So that's 27,500 kilogram meters per second. And let's give it in the units, obviously, because it's momentum. It's just the addition really of kilograms plus meter per second in terms of adding the units, adding the adding the units, but obviously times. Anyway, so sorry about that, just a bit confused. And then that is equal to 6,000 kg ms to the minus 1 plus 2,500 kilograms times v meters per second. And I'm just going to leave that as a sum there, so that is plus 2,500 times v meters per second. So that 2,500 would just be a kilogram. So what we do then is we sub minus 7,000. Oh my God's sake, this is too early. Minus 6,000 kilogram meters per second from both sides, so we're left with 21,500 kilogram meters per second. And that's equal to 2,500 kilograms times v meters per second. Obviously then it's just a simple case of dividing both sides by 2,500 kilograms. So that's 21,500 kg ms to the minus 1 over 2,500 kilograms, and that's equal to v meters per second. So therefore v meters per second is equal to some calculator. There's there's 8.6 meters per second. Because we asked to show that it's equal to 8.6 meters per second. So if you don't get that, then obviously you're going to be wrong. But so it's sort of a help really. So that's why it's only worth 3 marks really. Normally it would be more than that. Probably 4. Anyway, so that's how you would work that one out. Alright, so what we did was total momentum before, so we did the mass times the initial speed plus the mass times the initial speed of q and p. Then we put that equal to the mass times the final speed of both of them. However, we didn't know what the final speed of q was, although we were told that, we just had to show it. And then it was a case then of multiplying it out and simplifying it down and dividing both sides to get v meters per second on its own, and then you should get 8.6 meters per second. Okay, so the next one isn't too bad really. It's quite a nice one. So, as I said, hopefully you've got that down. You don't need to know all this information now. All you need to know is that the final speed of q is 8.6 meters per second. Okay, so I'm just going to rub that off a second, and I'm just going to write that next to q. So, as I said, you are given it really anyway, so you don't need to know that. So I'll just put, next to q, I'll put v is 8.6 meters per second. So obviously q is accelerated. It's gone from 5 to 6. Because the speed of momentum of p, some of that's been passed on to q, so it's sort of giving it a boost of speed. That's why it's increased. Okay? So that's quite logical, really. So, the next little paragraph says, after the collision at A, so we're just assuming it's A is where they hit each other, the truck P is acted on by a constant braking force of magnitude 500 newtons. The truck P comes to rest at point B. Okay, find the distance AB. So basically what it's asking is where the truck P has an impact. Obviously, because it's transferred some of its momentum onto Q, then it's going to... After that, it's then immediately after that, it's acted on by a braking force. So basically, this guy at P has hit Q and thought, oh no, I probably need to apply the brakes at this point, and stopped. Okay, so obviously he's not going to stop straight away. So when he stops, say the collision occurs here at A, and he's going to be going all the way to B. And what they want us to do is find a distance A to B. Okay, so this is not really it looks like a vector thing, but it's not. Okay, so right, obviously, as there always is in maths or physics, there's a couple of ways of doing this. But the way I did it, I'm sure it's particularly the long way round. What I did was, okay, I thought, right, well, it's telling us it's acting on, it's having a braking force of 500 newtons. So that's obviously some kind of force, resultant force, because he's not going to be going forwards if he's having a braking force. So it would be a bit stupid to do that. So therefore, it's going to be a force. Therefore, when he's braking, it's going to be a force pulling him this way of 500 newtons. So if we're looking at the resultant force, then the resultant force is going to be negative. So I put F is equal to negative 500 newtons, because there's a resultant force going in the opposite way he was initially going, at 500 newtons. Okay, and it's asking us to find the distance AB. Now, as we said before, obviously the P is passed on some of the momentum Q, and he's decelerating. Okay, because his speed's gone down from 10 to 4, and and he comes to rest at point B. So actually, you don't really need to know about the collision. So he's applying a braking force, obviously he's going to be slowing down, and he comes to rest at B. So therefore, that clearly states, okay, he's decelerating. So what would we use? So we know the mass, okay. So we know force, we know mass, which is equal to 1,500 kilograms. So we can sort of ignore Q for this point, and we want to know what A is, or minus A, or whatever. We need to know the deceleration or negative acceleration. Okay, so the only one that links them together is F equals ma. So first thing I do is write down F equals ma. Now the reason we need to, so I explain this, right. So the reason we need to, that's all we can do, that's all we've got so far at the start of the question. So even if you didn't know what to do next, then you'd still get some marks for doing this, okay? So we've worked this one out, so therefore if we rearrange to get A equals force over mass, put our numbers in, so A equals F over M. So F is minus 500 newtons over 1,500 kilograms. Therefore A is equal to, it's going to be minus 1/3 meters per second, minus 1/3 meters per second squared. Okay, so we've got a value for A. So that'd be equal to 0.3 recurring, but I'm just going to leave it as a nice fraction. So that's very good. We worked out the deceleration, but it's not quite asked us that. It says find out the distance AB. Now, to find out the distance AB, because it's decelerating, we would need to find out what it's decelerating at. And we've worked that out by just rearranging F equals ma. So we don't need this resultant force anymore. Our next stage, because we want to know the distance, so to recap what we now know. So we found out A, okay? We want to know the distance, S, in meters. We don't know that. We know the initial speed, which is actually 4 meters per second, because we're not taking it from, this braking force wasn't applied before the impact. So the initial speed was actually the final speed of the, so basically, part one of this journey is him going, this P going from the initial point to the collision, and then the second part is going from the collision to stopping at B. So we're interested in the second part. So therefore the last velocity of the first part becomes the initial velocity of the second part. So that's why we've got the final velocity here being the initial velocity. And then obviously the final velocity of the second part, because we said it comes to rest, is 0 meters per second. Okay? So we know A, we know U, we know V, and we want to know S. So the only equation that we've got that links them is V squared equals U squared plus 2AS. So V squared equals U squared plus 2AS. Now, at this stage, you could, one other way of doing this, if that didn't pop out to you straight away, you thought, oh, well, we've got a change in velocity, and we've got acceleration, we could work out time from that, and then you could go, okay, work out a value for the time taken to stop, and you could go, okay, well, S equals a half U plus V times T, and you could go from there, but you added in an extra step, and it's not worth it. So anyway, this is quite a nice one. So obviously velocity, the end velocity is going to be 0, so 0 squared equals u squared, which is 4 meters per second squared, plus 2 times a, which is 2 times negative a third, times s. Okay, so therefore, it's 4 meters per second all squared. So that's going to be 0 is equal to 16 meters per second squared minus 2/3 times s. Okay, so you rearrange that, so you get the s on its own, so therefore 2/3 of s is equal to 16 meters per second. Now what you could do is meters per second squared, sorry. Now what you could do if you wanted to is simply divide both sides by 2/3. Although what I prefer to do, because I'll probably end up getting myself muddling the calculator with that, is times both sides by 3. So therefore we get 2 times the distance, meters, is equal to 16 times 3. That's 30 plus 18, which is 48. And divide both sides by 2, which s meters is equal to 24 meters. So distance is equal to 24 meters. So therefore the distance A to B is equal to 24 meters. So don't forget to state that at the end, because you could put distance is 24 meters, but you don't know what that's the distance of. I mean, you do, but the examiner being picky probably wouldn't. So, but I can't be bothered putting that in, you know, because it's too good at this. Okay, so that's question part B. There's only one more little bit here. So it says, after the collision at Q, I'm going to leave this on the board actually and just fit it underneath because you do need to know part B. So it's part B, yeah. So part C says, after the collision, Q, which is this one, continues to travel at 8.6 meters per second. So just like we said, the initial speed here, the final speed here was the initial speed for the second part after the collision, and we said the final speed for P in the second part, so the final speed, this makes any sense, so after it applies a braking force, it's going to be 0 meters per second. So in this case, we've applied the same thing. The final speed of the first part, before the collision, is the final speed in the first part after the collision is 8.6 meters per second, and then the final speed of the second part, we are told, is also 8.6 meters per second. Okay. Find the distance between P and Q at the instant when P comes to rest. Now I know this sounds a little bit stupid, but I think it's quite a good way to get into this question. Even though it's, when I say stupid, it's not really. It's just a bit, you know, it makes me look a bit thick. But that's me, not you. So you can say it was all my idea. If you get caught, I don't know who's going to catch you though. But, you know, never mind. So the distance between P and Q is what? So distance between P and Q is equal to distance travelled by Q, because obviously Q is going to be greater, minus distance travelled by P. So the reason that we need to do this, I mean, it does sound obvious, but if I'm not explaining it very well, I would understand. So what we're going to assume up here is, I'm going to say, okay, well, I'm going to give P, I'm going to denote that by a little red line, and for Q, I'm going to keep that as a blue line. So I'm not going to include the velocities of this, so just assume we're starting at the same point for both of them. So we start here for P, sorry, here for P and there for Q. So they're starting at the same point really, but I'm just denoting it by two separate colour lines. So obviously after the impact, P starts to slow down and it becomes to a stop. So if it's slowing down, it's not accelerating, obviously, and it's not going at a constant speed, so it's moving the slowest distance per second. So it's going to be something like that, okay? It's going to be, I mean, in terms of the lines comparison. And because Q, at a constant speed, it'll be moving faster than P. Because it initially is anyway, but because it's not changing its speed, it's just covering the same meters per second, meters per second, meters per second. It's going to be, when P is decelerating, Q is going to be carrying on, okay? So it's going to be a bit further, okay? So what it wants is the distance between where this blue line ends and where this red line stops, okay? So that's what it wants. It wants this distance here. So that's why we have to think about this, and we can't just work out the distance travelled by Q, which is what some people did in the exam. Okay, so I tried to highlight a little thing there. Now, what we've just worked out in this part is we've worked out the distance travelled by P. So what you could replace that with, so I'm only going to do this because I don't quite have enough space in my diagram, is to write that the distance travelled by P is equal to 24 metres, so I'm just going to replace that 24 metres. So the only thing we need to work out is the distance travelled by Q. Okay, so the distance travelled by Q, right, well, first of all, it's going to be a CVAT equation. So we need to write down what we know. Now we know the initial speed in the second part is the final speed in the first part, so that's 8.6 metres per second. And as we're told that there's no change in velocity, because the final velocity is also 8.6 metres per second. Therefore, the change in velocity is going to be 0 over a time period. We don't know what that is. So that is going to be 0 metres per second squared for the acceleration. It's not going to be any, but it's not decelerating either. And we want to know the distance in metres. Okay, so similar thing to what we did before, is we could use exactly the same equation. Don't know what that is. So P squared equals U squared plus 2AS. Oh, well, sorry, no, that'd be a little bit difficult. Actually, no, don't use that one, it's a bad example. So, it's just my alarm, that. It's a very advanced alarm, that. It just goes off randomly. Only about an hour or two too late. One sec, sorry, I'm just going to double check what they used for their answers. So I'm sure it'll be on the mark screen. One sec, come on. Sorry. I do apologise about this. Alright, sorry, one second, I'm just trying to find. I was looking at the wrong question. I was looking at question 7 on my thing. Sorry about that. Sorry, I do apologise about this. I'm sure the answers are on the line somewhere. Alright, okay. So the only other equation, sorry, for the displacement is S equals ut plus a half at squared. Now, as a is 0, that's going to mean the half at squared is going to be 0. So therefore, the displacement is going to be ut, which is 8.6 metres per second times time. Okay, but we don't know what time is, but I'm just going to leave it in there for the moment. So S is equal to 8.6 metres per second times t. So, to work out t, we could say, this isn't very good. wondering why this is all going so long. If I had all the sheets, mostly don't. See, I'm trying to not, oh, there we go. Right. Oh, right, yeah. So, are we told T? Sorry, I thought, are we told T? No, we're not told T. Oh, right, sorry. I missed quite a crude bit out. So, right, so we can't work out T on its own from this equation, which is what I was trying to do. So what we need to do, I really should have left myself a little bit more space down there. So what we need to do is work out the time it took for P to stop, and then we can use that time period to work out how far along Q has got in this time. Okay, so we know the final speed, so looking at P now, sorry. So we know the final velocity was 0, so V equals 0, U equals 4 meters per second. We don't know what, sorry, we know what A was? Yeah, we know A was negative 3 meters per second. Okay, squared. So therefore, you just put V equals U plus AT. So therefore, 0 equals 4 meters per second. Take a third times T. So therefore, if you multiply this out, so therefore, 0 times 3 is 0, 4 times 3 is 12, so 12 minus T is 0, so therefore T is equal to 12 seconds. Okay, so that's where we get T from. So therefore, this is just a case of putting it into this part here. Therefore, S meters is equal to 8.6 times 12, so therefore 8.6 times 12 is equal to 103.4 meters, if I'm correct. 103.2 meters, sorry. But that's not the final answer, that's how far Q has travelled. So if we have to put it into this equation above, so we have to take 24 meters from that to get our answer of 79.2 meters is the difference. Okay, so that's how you'd work out that one. So sorry about that little mess up there. I'll leave that in just for your enjoyment. So thanks for watching. As I said, hopefully it's made some kind of sense. That's worth a nice 11 marks on the paper. As I said, it's just really just using your A2 physics knowledge of momentum, or GCSE knowledge of momentum, really. There's nothing more to it. So it's basically just using an idea of momentum and adding it into your SUVAT equation. So it's a nice double topic, really. So thanks for watching, and we'll see you in the next video.